Good morning. This is your Stat Sensei, Mr. Spensei, and this video warm up is a review of the empirical rule because our lesson will be building into central limit theorem and we want to contrast the differences. So this was only going to be focusing on the empirical rule. So IQ scores are normally distributed with a mean of 100. Go ahead and label that down. Mean equals 100 and a standard deviation equal to 15. Label the mean and standard deviation as well as z-scores to be certain to include the percentages associated with the empirical. All right, so my z-scores, all z-scores, and I'll start there, are zero, begin with zero. And we have one standard deviation, two standard deviations, three standard deviations. And technically, this goes all the way to positive infinity. So there's our positive z-scores. Then we have a negative one standard deviation, a negative two, negative three, and this goes to negative infinity. And that's our z-scores, our negative z-scores. But we have an actual mean of 100. And they're telling us our standard deviation is 15. And by the way, this is generally accepted IQ scores right here. So the distance between each one of these is 15. So 100 plus 15 is 115. 115 plus 15 is 130. Add another 15 and I get to 145. Taking away, we drop down to 85. Take away another 15, we drop down to 70. Take away another 15, and we drop down to 55. But we're supposed to label our empirical rule, and by empirical rule, plus or minus one standard deviation for the normal curve for all normal curves is 68%. All right, plus or minus two standard deviations for all normal curves, not just the standard normal, but all normal curves is 95%, and plus or minus three standard deviations is approximately 99.7%. Please remember the empirical rule is an approximation. It's not exact, it's close. So, what percent of IQ scores are between 55 and 145? Well, real quickly, we can see, oh, that's plus or minus three. That's 99.7% based on the empirical rule. What percent are between 70 and 130? Oh, that's quickly seen looking at this at 95%. And what percent are between 85 and 115? And that would be 68%. What percent of IQ scores are above 100? Well, 100 is the mean. And because it's the normal curve, the mean, the median, the mode are all occur at the same place, and it's symmetric. So half is above 100, half is below 100. So without doing any calculations, because this is in the middle, I know that this is going to be 50%. Just looking at the picture because it occurs as the mean. The next one, use your calculator. Answer the following question. How likely is it that a randomly selected individual has an IQ score greater than 120? Well, I can look here and it's like, oop, I don't have that. So what do I need to do? Well, I'm looking for the probability that X is greater than 120. Well, I'm going to draw my little picture. My little picture says, hey, we have a mean centered at 100. We want the probability that we have a 120 or greater. This is going to positive infinity. And I'm looking for this area right here. Anytime they ask you for a probability or percent, we're going to use a norm CDF. So in this case, I'm going to use a norm CDF because I'm looking for that shaded portion. So norm CDF. And when I go to my calculator is going to, the very first thing it's going to ask for is the lower part. So let's look and see what it asks for. Second var is norm CDF. It asks for the lower part of my shading, the upper part of my shading, and the mean and standard deviation. Well, the lower part of my shading was 120. The upper part of my shading is positive infinity. The mean occurred at 100, and they told us for this problem our standard deviation was 15. So this is our LUMO, lower, upper, mean, and our standard deviation symbol. So I'm going to plug that in. Lower, 120, upper, 9 raised to the 99th, mean of 100, standard deviation of 15, and I end up getting 0.0912. And I box that in. All right. All right. Appreciate you watching. Hope that helped. Look forward to seeing you on the next one. Thank you.